After we grade the mock exam Oreo notes, like take them home to study it, or
we'll talk about that. All right, here we go. So this is the graph of the function f consisting of 3 line segments is given above. Let g of x be equal to the integral from 1 to x of f of t dt. So whenever you see this notation here, we have a function that's equal to the integral from, in this case, 1 to x, and there's a different variable there in the integrand. This signals that it's the fundamental theorem. And so you are expected to write g prime of x is equal to f of x. So I take the bound and I plug it in, and then technically I multiply by the derivative of the bound, but in this case it's just 1. And it follows from this that g double prime of x is equal to f of x. Excuse me, f prime of x. Okay, so they're probably going to ask you one of 3 things. G of x, something about g of x, which would be the value of the integral, which is the area under the curve. G prime of x, which is equal to whatever f of x is on the graph, or g double prime of x, which is equal to the slope of the graph of f. Okay, so the first part says compute g of 4 and g of -2. So those are going to be the values of the integral. So I'm going to go ahead and find the areas under the curve first, breaking this down into its geometric shapes. So I've got a triangle with a base of 3 and a height of 4. So my area is 6. I've got a small triangle here with a base of 1 and a height of 1. So that is 0.5. Got another small triangle with a base of 1 and a height of -1 below the x-axis. So that's -1/2. And then I've got a trapezoid. And oh, it's Monday. What is the area for a trapezoid? It's height divided by 2 plus b1 plus b2. And the height in this case is the x value. And the bases are the y values. So I've got a base of 4 and 1. So the area under the curve from 1 to 2 is 2.5.
I'm going to do the middle one from 1 to 2.
I just did. That's the trapezoid. Okay. So part A says compute g of 4. So g of 4 is going to be the integral from 1 to 4 of f of t dt, which means it's the area under the curve from 1 to 4. So I've got 2.5 plus 1/2 minus 1/2. And so that area is 2.5. And then it says g of -2. And so notice that the bounds are reversed. It's going from 1 to -2, so it's going backwards. So I need to switch the bounds and make it negative. Which means I have an area of -6. Okay. Any questions on the first part there? Okay. Sure. Part B. Sure. Part B says find the instantaneous rate of change of g with respect to x at x is equal to 1. So this is the derivative. And I know that g prime of x equals f of x. Therefore, g prime of 1 is equal to f of 1. So I'm going to look at the graph and find f of 1. And that tells me that f of 1 is equal to 4 because x at 1 is defined at 4. Okay. And part C says find the absolute minimum value of G on the closed interval from -2 to 4. Justify your answer. Okay, so this right here, if I'm reading this, okay, if I'm finding a min or a max, it has to be a critical point, or since the endpoints are defined, it could be an endpoint. So I'm going to justify it first. So the justification, we say the minimum value of G occurs when does it occur?
When X equals.
When the derivative, when G prime of X, and G prime of X is equal to F of X in this case. So G prime of X equal to F of X is 0 or undefined, and changes signs from negative to positive. So if you were looking at the graph, let's check the undefined part. The derivative of G is equal to F of X. So there are no points on the graph that have a hole or an asymptote. So it is not undefined. So I can throw that out. There is a point where F of X is equal to 0. That occurs at 3 because the graph crosses the x-axis. However, this is not a minimum. It is a maximum because it changes, it's above the x-axis, then it's below the x-axis. So it changes from plus to minus. And so it's a max. So I said X equals 3 is a max. So we are going to check the endpoints. So we want G of -2. And we just found G of -2 in part A. G of -2 is equal to -6. And the other endpoint is at 4. So G of 4 is equal to 2.5, which we found in part A. Therefore, -6 is lower than 2.5. So the absolute minimum value occurs at -2. So I'm going to say, therefore, the absolute minimum value is G of -2 equal to -6. Yes.
Do we have to write all that, or do we just do a consider list and then explain why negative to that?
You need the first part there,
Yeah.
for the justification, but after that you can do a consider list. That's okay. And then say you've got to have that first line there for the justification. But if you do a consider list after that, that's fine.
Well, I didn't put the changes from negative to positive because it's an endpoint, so I just said increasing after.
That's fine. Or if you've already listed, if you've already found these two values, if you do your consider list and list those, then that's fine.
Wait, coach, for the endpoints, you can either do what you did and check the values, or you can just like look at it visually.
No, you have to do that.
Well, like what Rachel said, like can't you just say that like it's positive right after? So
But okay, but it asks for the actual minimum value, and the only way that you can get that is by what we did in part A.
I didn't see that.
You can find where it's at.
Yeah.
If both of them happen, if one happens to be a min and the other happens to be a max, but in order to get the actual minimum value, you've got to
but like if
find
it's
the
just
end.
asking for it.
Okay, part D. It says the second derivative of G is not defined at X is equal to 1 and X is equal to 2. So stop right there for a second. Why is that true?
Not differentiable.
Okay, the second derivative of g is equal to the first derivative of x, and they are not differentiable at 1 and 2 because the slopes are not the same on either side.
No cap.
All right. It says how many of these values are x coordinates of points of inflection of the graph of g? Justify your answer. So let's justify it.
Oh, no.
Point of inflection occurs when g double prime of x, which is equal to f prime of x, equals 0 or undefined, and what else must be true?
It's continuous. Indifferentiable.
Oh,
Change signs.
just throw some calculus terms out there and hope something sticks, right? And it changes signs. So looking at the graph,
I know.
does it change signs at x is equal to 1?
Yes, sir.
And the answer is
No, it doesn't.
yes, because you have a positive slope on the left and a negative slope on the right. Does it change signs at 2?
No.
It does not, because you have a negative slope on the left and a negative slope on the right. So we say g double prime of x, which is equal to f prime of x, equals undefined at x equals 1 and 2, but only changes signs at x is equal to 1. Therefore, there's a point of inflection at x is equal to 1.
Listen, then you get a 500 message.